Okay, so the main things to note about the photoelectric effect is that we shined a light at a piece of metal, and if only above a particular frequency known as the threshold frequency were the electrons emitted, electrons liberated, I should say, from the metal. If the frequency was not above that threshold frequency, F0 or F0 or whatever it is, FO, then they weren't liberated. They stayed in the metal. Um, once you did once you went past that threshold frequency and continued to increase the frequency, the number of electrons stayed the same. The number of liberated electrons stayed the same, but the kinetic energy of those electrons increased. Okay, and and then he found out that once above the threshold frequency, if the intensity was increased, then the number of electrons stayed the same. However, their kinetic energy remained the same. So, so looking at the photon model, then we can imagine this little thing here as just a photon. Then let's get rid of that diagram of a wave, and we'll just draw a little circle to make that can represent our photon. Let's make it yellow. That seems like a sort of colourful light. So it's coming along at this electron, gets absorbed by the electron, and if it's enough, it gets absorbed by the electron, and then if it's enough, it will escape out. If it's not enough, then when it gets absorbed, then it might not have enough energy to escape this energy well. So you can imagine this is kind of like a graph or diagram and that amount of energy is the energy required to escape the metal. The name of that energy that is required to escape the metal is known as the work function, Greek symbol phi. So so then this means that the equation would make sense. So for reasons that I won't go into at this stage, partly because you don't need to know it really, the energy of the photon we can calculate by multiplying Planck's constant by the frequency of it. I mean, it's weird to think of it as having a frequency if it's not a wave, but in any case, that's how you would calculate the energy of that photon. So the energy of that photon is being then used, if it's enough, it's being used to liberate the electron, and it's also being used if it has anything left over to provide the electron with some kinetic energy. So this is only if HF is greater. I don't want to say greater or equal to. No, I'll just say greater. It has to be greater than the work function. If it was just equal to the work function, then it doesn't actually have any energy at all to actually leave. It still needs some kinetic energy to move. So anything greater than the work function would you could then use this relationship here. So that's the basics. I'll just cut that video there, and then we'll look into it a bit more detail now.